In this video, we're going to solve 2004 AP Calculus AB FRQ question. So number 3 says a particle moves along the y-axis so that the velocity v at time t is greater than or equals 0 is given by v of t equals 1 minus the inverse of tangent e of t at time t equals 0, and the particle is at y equals -1. Note that the inverse of x equals arctan of x. Okay, well, you should know that. Part A, find the acceleration of a particle at time t equals 2. So pretty easy, use your calculator. So let me just get rid of this box so I could start typing. Okay, so for part A, you got to do a of 2, which is going to equal v prime of 2. Type it into your calculator. When you type it in, I got approximately -0.133. Part B. Is the speed of a particle increasing or decreasing at time t equals 2? Give a reason for your answer. So we need to know what v of 2 is. So v of 2 is, let me check what I got. V of 2 was -4.36, and a of 2 was -0.1333. So the particle, so the speed of the particle, is increasing at t equals 2, since the v of 2 and a of 2 have the same sign. Okay, part C. Let's do it up here. It says, find the time t is greater than or equals 0, which the particle reaches its highest point. Justify your answer. So I would graph this and look to see where it has a max. So when you graph this, there's only one point where it has a max, and that's at t equals approximately 0.443. And the reason for that, is the slope equals 0, and the sign changes from positive to negative. I forgot the positive. Okay, to negative. Everywhere else after that went down, and when you actually looked at the graph, let me draw it, kind of looked like this. So that's the max. This could be a max, but it's the beginning and it's traveling upward, so it's not going to be the max. And then once you pass the 4.443, it kept going downward. So that would be a min, the other endpoint, but we don't even have a boundary for that, so it wouldn't apply. D says, find the position of the particle at time t equals 2. Is the particle moving toward the origin or away from the origin at time t equals 2? Well, one important part is, in the beginning it told us t of 0, t equals 0, y equaled -1. So if it's past -1, it's not going to work. So when you do this, you're going to get y of 2 is going to equal -1 plus the integral of 0 to v of t dt, which is -1.361. So v of 2 was also negative, so the particle is moving away from the origin. So if you go back to your graph, this graph that I have here, so let's say -2 is here. This is where the origin is. That's where it hits. So let's say, well, that's -2. So at some point over here, this area in this area, let me change colors, are equal, and then that's when they would be the same. -2 happens to be a little bit more area, so you have more negative area. Let me change it to a better color, blue. You can see blue. So if you look, actually we can't even see that. Let's try white. Definitely can see white. Let me erase it. I think all these colors are messing it up. So anyway, so if you do this, there's actually more negative area because the pink and the green canceled one another out. Alright, I hope this video helped, and I'll see you guys next time.